I would like now to discuss a very important and peculiar timer function on our microcontroller, which is called the Watchdog timer. In embedded systems, you have to cope with potential hardware and software anomalies and be extremely robust. Because in many cases, embedded systems will operate in total isolation and not be accessible to an operator that cannot actually come and reset your system. So you should be able to deal with software hangs as easy as possible. In extreme cases, of course, it's not only an inconvenient process to come and reset your microcontroller, but you can end up with damaged hardware or even loss of life in case of a software anomaly impacts on your system. Let me take a few examples from the space exploration. In '94, a deep space probe named Clementine was launched to observe the moon and some large asteroids. After a couple of months of operation, a software exception just triggered and ended up controlling the thruster that did fire for 11 minutes, which almost emptied all the fuel and made the probe to rotate at 80 rotations per minute. The control was eventually regained on the probe, but the mission was not successfully completed. So a software anomaly did cost you a complete mission in that case. A more recent example, the Mars Pathfinder rover, launched in 1997, suffered a software anomaly once again, where a priority inversion was made on a real-time operating system, and that basically made your communication to wait until a low priority science task was operated and everything locked on a mutex. So the bottom line is that it was impossible to communicate with a probe and do anything on that probe. Well, it turns out that the mechanism was implemented, the Watchdog timer, that discovered that the software has hanged and resetted the Mars rover, where the Earth control was able to regain control and patch the firmware on the fly. And that way, the entire $200+ million mission could be saved and completed successfully. But you had this software bug, and the only way to recover from this software bug was to use this mechanism of Watchdog timer. So what is that exactly? It is very unlikely that you'll be able to cope with all hardware and software anomalies. It's very hard to debug once again. When I mentioned embedded systems at the very beginning of this class, you do not have easy way to debug or to program. You need to use cross-compilation toolchain and so on and so forth. It's pretty hard to actually get into the things. So in order to compensate for that risk and mitigate that risk, developers are using Watchdog timers. So Watchdog timer is a hardware timing device, a regular counter basically, that once you overflow this timer, it will reset your device. So in order to avoid your device to be resetted, you want to regularly reset your timer. Reset your timer to 0, so that the bottom line is that if the software as an anomaly is stuck somewhere and is not able to reset this Watchdog timer, you will end up after a period of time to reset your entire system. It is possible to find both external and internal Watchdog timers. External Watchdog timers being totally separated devices that do count time and that will activate the reset line on your MCU if needs be. Internal watchdogs are actually built-in circuits within your microprocessor or microcontrollers, and that is available for the programmer for a very low cost. They typically are mapped to an NMI or the reset, and triggers that when the counter reaches a predefined value. Your watchdog will be controlled by a user interface, so you have a special instruction to reset this timer. So while of course it is not as safe as a fully external circuit, because your watchdog might actually suffer from issues, hardware issues in the processor. So if the NMI is not responsive, your watchdog will not trigger anything. You might have errand codes that are going to overwrite your watchdog while you should not. And the reset is limited to the processor itself. You are not resetting anything else on the board. So even though it is slightly less safe than an external watchdog circuit, many hardware designers understand microcontroller manufacturers do have extra safety steps that do prevent those kind of operations. So nowadays, using internal watchdog timers are pretty cost and space efficient solution. Now there are a couple of design configurations you need to consider. The bad way of using watchdog timer would be to simply reset your watchdog timer every couple of instructions so that no matter what happens, boom, you reset things. Well, that's a pretty bad way to do things. A much better way to do that would be to take a proactive approach, where you will periodically assess the state and the health of your system. You can check whatever registers, you can check where you are, you can look at memory heap and stack, do some preventive actions. If you detect something bizarre, you will let the dog triggers. Otherwise, if everything is deemed clean, you can reset the watchdog timer. You'll have also to consider a state-based approach when resetting your watchdog timer, where, for example, you might have different levels of fail modes, where you will look at different states that create potential problems, and you should keep track of debug logs. So if your watchdog timer kicks in, you will be able to look into a memory location, essentially in your flash memory, and being able to understand an error code that will help you debug things further.